This video describes a two-layered approach for placing a deformable linear object called DLO on a flat surface using a single robot hand. The high-level layer is the DLO surface placement planner based on Euler's Elastica solutions, called the placement scheme, consisting of 3 stages, which will be demonstrated by a simulation and experiment. Let's see the simulation and then describe the stages on the real example. In stage 1, the robot arm transports the DLO, remaining vertically under gravity, until the DLO tip touches the placement surface, this point called the attachment point. In stage 2, the robot arm holds the DLO distal tip and executes non-slip rolling of the DLO's tip. The tip keeps contact with the surface, until the DLO tangent at the tip aligns with the surface at the attachment point. In stage 3, the robot arm executes non-slip rolling of the DLO's contact-free part, until it is fully placed on the surface. In our experiment, the placement surface is a packing tray placed on a work table. The low-level layer contains the pipeline controller uses a residual neural network. The observed DLO shape and the planned one used to compute the accuracy error, which is fed into the local feedback controller, then the controller commands the robot hand. This experiment was performed on 4 silicone mock-up objects. At the right screen, an overview of the overall system is shown. At the middle screen, a close-up of the environment in the eyes of the camera. At the left screen, the control pipeline is demonstrated. The pipeline controller consists of 2 stages. Finds the medial axis and characterization. YOLO V8 model crops the obtained frame from distractions, then by using the image mask and classic image processing, extracts the DLO's medial axis. This can be seen at the left screen as the blue background being overlaid on the crop shape. The medial axis becomes the input to the ResNet network. The output is the predicted Elastica parameters. The shape created from the predicted parameters is represented by the black dots on the left screen. It appears that the black line is not stable because of the robot movement. The solution is to take the average accuracy error of 20 sampled shapes based on the average error the controller gives the command. In the second experiment, the accuracy error is large, so the robot enters a recovery mode and make a replan. The image visibility on the controller is reduced, so the system can give the feedback in real time. The pipeline execution time is 20 milliseconds. Despite the image quality, good recognition results are received. This video illustrated a practical realization of the DLO plan placement path, monitored by a low-level perception control using a machine learning pipeline execution in the presence of modeling and placement errors.